All right, so far we've covered supervised learning, which is where you're feeding the computational model training data that is labeled, that the computer can understand and it can use it to classify or perform regressions. The next type we talked about was unsupervised learning. And this is where you feed the computational model a whole bunch of data, and the computer tries to make sense of that data and tries to give it structure, be it using clustering or be it using another framework. Now we're going to talk about reinforcement learning. You can see where I'm going with this school analogy. Now, when I was in school, growing up in China, I had a lot of reinforcement learning. From memory, the various things that have been used to reinforce learning include chalk, chalkboard duster, as well as one teacher who decided to throw her high heels at me because I refused to memorize a poem when I was age 7 because I said, well, it's in the book. Why don't you just read it in the book? Why do I have to memorize it? So clearly, reinforcement learning works very well on me, and it works also very well on machines. So enough about me. What exactly is reinforcement learning? Well, if you think about it, as humans, we tend to learn through reinforcement, right? If you touch something that's hot and it burns and it hurts you, then you're going to learn to not do that in the future, right? So that's a form of negative reward. It's a way of punishing particular behaviors that lead to probably the demise of our species. So imagine if none of us had pain receptors. Then we would run around hurting ourselves in all sorts of creative ways, and the human species wouldn't have lasted for long enough for me to talk to you about reinforcement learning. So this is a form of negative reward, but there's also positive rewards. Then maybe you'll be rewarded by the teacher or by your parents. And if you look at dog training, you can see that one of the most effective ways of getting your dog to do something is by rewarding it. So, for example, if you're trying to tell it to sit and it does sit, then you give it a treat, then it knows, oh, I did the right thing. I did the requested thing. I'm on the right track. So this is reinforcement learning. And one of the most famous applications of reinforcement learning is with these games like chess. So let's say that the guy on the right is a machine that is using a reinforcement learning algorithm. Even though he's making moves continuously, he's probably only getting that reinforcement at the end of the game, where he finds out whether he won or whether he lost. However, he can continuously calculate his probability of winning. So if he makes a particular move and it increases his probability of winning, then that's a positive reinforcement for that move. But if the opponent then counters that move very easily and it reduces his win probability, then that is negative reinforcement. So through many, many cycles of training, through practicing many, many games, the computer is able to learn on an ongoing basis which moves in which situations are more likely to lead to an increased probability of winning, i.e. an increased probability of getting that reward. So one of the real life applications of reinforcement learning is in Google DeepMind's AlphaGo. So this is a machine learning algorithm that uses many different types of deep learning, actually, not just reinforcement learning. So if you haven't heard the news, recently AlphaGo has won in 3 games out of 3 against the world champion in Go. So for those of you guys who don't know, Go is this incredibly simple game where you have only black and white pieces, and the aim is to surround the opponent using your own pieces. And when you surround them, you're able to eat their pieces. So it's an incredibly simple game in terms of rules, but the actual permutations on a 19 by 19 board are actually larger than the number of atoms there exist in the universe. So it is one of the most complex strategy games known to and played by man. And recently, AlphaGo, which is based on the machine learning algorithm developed by Google's DeepMind, managed to beat the world's #1 player in Go. So I love this image because it says the future of Go, but it probably should be renamed to the future of mankind, where man sits there looking puzzled as the singularity takes over and we become some sort of minor race that's ruled by computers. So here's another great reason for understanding machine learning. At least you might have a chance of standing up against our machine overlords if you understand at least a bit about how machine learning works. So the point that I'm making is that AlphaGo is an artificially intelligent program that uses machine learning, more specifically various forms of deep learning, including reinforcement learning, to evaluate each and every move based on how likely it is that it will increase or decrease the final outcome. So one of the really interesting things about AlphaGo is that it's been trained on thousands of historical Go games, more games than a human could possibly hold in their memory or having played in their lifetime. And through reinforcement learning, it's able to figure out under which conditions, which moves will confer it an advantage in winning. And the really interesting thing is that it's programmed to win under a binary condition, i.e. win or lose. It's trying to optimize for the winning condition, but it's not trying to optimize for winning by the largest margin. So when it's doing really well in a game, it won't necessarily try to beat you into the ground, and it's only aiming for that final win condition. So this is a good point to say that machine learning has so many applications in the real world, and it's going to become increasingly important in software development. So we've spoken about some of the most common types of machine learning, and it's really, really awesome that Apple is bringing it into the iOS world using CoreML. So without further ado, I think we should get into an example and get stuck in implementing CoreML in our very own app that we're going to build from scratch. So in the next module, I'm going to introduce you to all the tools and all the things that you need to download in order to get CoreML to work. And we're going to get started creating our image recognition hot dog or not hot dog app. So I'll see you there.